Hi there friends, welcome to Civil Engineering. My name is Elvis. I hope you are all fine. Today we'll be looking on arrangement of reinforcement of top beams or reinforcement arrangement of top beams. And before we continue guys, do not forget to like this video, and if you are new, subscribe and you hit on the notification bell to always have the latest updates from this channel. Guys, how do we arrange the top beams? We do that when our distance between, because this is the pillar or column, from this pillar to this pillar, if the distance is maybe above 4 meters, we need to provide this creek bar. This is creek bar. Hope you are seeing it from here. This is development length. Development length, it is always provided to create a good bond between pillar and the beam. It is always provided to create a good bond between the pillar and the beam. And here, you always act to resist the shear stresses, because this is where the shear stresses will occur, and down here you see this is where the bending moment will occur. So here it is compression. Up here it is compression. So concrete it is always weak in tension, because here it is tension, and up it is compression, because this is how it will compress. Imagine that this beam, it is deforming. This is how it will be. Imagine that this beam is like this. This is tension and this is compression. So you see, this is tension. So concrete, it is always weak in tension and strong in compression. So I hope you can really see how it is working. And this creek bar, it is provided to resist the shear stresses, to resist the bending moment, because from this cutting, because this is where we have cut the first cutting. This is as we cut, this is what you are seeing. This creek bar, you are seeing it. This that you are seeing at the center. These two that you are seeing at the center, and it is always provided with rod 12. It also depends where you are using it in, but it should be at least from rod 12 to resist the bending moment. And even as it is resisting the bending moment here, it is also working here to resist the shear stresses, because this is where the shear stresses will always occur, from these corners near the support. Whereas the support, they are the pillars. So the shear stresses will always occur towards the support, and the bending moment will always occur at this middle or at the center of your beam. So to provide what will resist it, will provide this crank bar to resist the bending moment at the center, and here it will work to resist the shear stresses. That's why when you cut it here, this is what you are seeing. You are seeing this rod here. It is the one at this angle and the one with the other angle. And this creek bar, when you lift up here, you have to come here. It is two. So that's why you are seeing here. And when you cut it again here, when you cut it here at BB, because here is AA, so when you cut at BB, this is what you are seeing. When you cut and you are focusing that way, this is why you are seeing the creek bar. It is up. So that's why you are seeing but 4 rod up, and here you are seeing but 2, because when you cut it here, the creek bar, it is down. But when you cut it at the BB, the creek bar is already up. So that's why you are seeing but 4 rod up. And that's why you are seeing rod 12, 12, 12. 12, 12, it is down, because down it is always weak. Because concrete is always weak in tension. and strong in compression. So that's why we always advise to use a maximum steel rod in compression, where there will be compression. No, where there will be tension, sorry. Where there will be tension. And use a minimum at where it will be compression. So guys, I hope you can really see how it's working. And this development length, you always provide a good bond between the pillar and the beam. So this is your stirrups. This is your stirrup. This is your stirrup. The stirrup, you can see this bending, it is 135 degrees. The angle should be 135 to resist the shear stresses. And bending moment, because when you do not bend it at the angle of 135, it cannot resist. It can easily open. Imagine that it is just like this. Imagine it is just like this. Just at the angle of 90 degrees. If it is at the angle of 90 degrees, it cannot resist the shear stresses. When you want to resist, so when it is becoming tension, it can this angle can easily open. It can easily open. But here, at the angle of 135, it cannot open easily because it is bent at the angle of 135. No, 136. 135, guys. 135, sorry. 135. Angle 135. And this length, it should be at least 4 centimeters. 4 centimeters. According to my own research, guys, this is what I've made to at least advertise to you guys to know what you should do. And to know because this is the depth of the beam. The depth should always be greater than the width. The depth of this beam should always be greater than the width. That is why to know the depth, you need to use this length. Let's consider that this length, it is 6 meters. So when you use, to find the depth of this beam, we need to use length divided by 12, which is equal to 6 divided by 12. Equals to, when you divide this, you have it before. You can then use it to, before it will be the thickness of this beam. So this beam, if it is 20 cent, if it is maybe it cannot be 20 centimeters, because if the width is 20 centimeters, this should be at least 35 centimeters or 40 centimeters, because it is above, it is already 6 meters. So I hope you can really enjoy the video. Please guys, do not forget to like, you subscribe, and you hit on the notification bell to always have the latest updates. Guys, thanks for watching, and see you in the next video.